Good afternoon. My name is Cramer. I am representing the Geological Survey of Norway. And this presentation is a part of the contribution that we make towards the national program called Mariano, which is the mapping of the ocean floor, the marine territory that Norway has, which is about 7 times as big as the land area. And in this process, we've looked at particularly microplastics in the marine sediments. In other words, what is on the seafloor, the top part of the sedimentary column. My co-author here, Henning Jensen, is really the one who does most of the research in this case. But unfortunately, he is on sick leave and he couldn't make it, so he asked me to present it. The question here is about microplastics. As Amy was talking about, it was mostly the macroplastics and a little bit about the production. I will try to say a little bit here about what are marine microplastics. And the first part is that microplastics are, of course, particles, and there's a bit of a discussion on what is their size fraction. Usually it's always the longest dimension, and as of today it's still officially or internationally it's less than 5 millimeter. But as Amy is part of an expert panel, the GSAMP, that now considers maybe less than 1 millimeter is the proper size dimension for microplastics. Generally, we can say that they are not visible to the naked eye. The source of microplastics in the marine environment, there are two sources. One is the primary production. These are both raw materials, but also specific uses. For instance, all the fine particles, microplastic particles that are produced for cosmetics and for scrubbers, but also the raw materials, the nurdles as they call them, for subsequent production of different products. The secondary product as a source is the degradation or the abrasion of macroplastic that also forms the fine particles that we then call microplastics. In terms of the properties, there's of course the chemical and the physical properties. There are, as Amy was telling you, that's the organic polymers, but microplastics also have a lot of additives to the original base polymer, and of course they also, through absorption, have chemicals absorbed to the original microplastic particles. In addition, there are targets for bacteria that attach themselves and stay with the particle. The physical properties, shape, density, and absorption are also very important in their life cycle. And here I would like to just illustrate a little bit about the shapes that we find them in. There's essentially beads, like I said, in scrubs and detergents, and then the nurdles. But there's also fibers, and the flakes or foams, films, are often found as well in different shapes, and they are found in the marine environment, in particular, everywhere. And that's essentially what I try to illustrate here too, that microplastics, MPs, as I call them now in the next slides in my presentation, are found basically in the marine environment along the shoreline, on the beaches, in floating garbage, in seawater, in sea spray, and as the recent media focused on in January, it's also observed now a lot in sea ice, but it's also in sea salt, in biota, and in marine sediments. So in other words, we find microplastics in the marine environment everywhere. This following slide, Amy already showed you as well. It essentially is the way that microplastics enter into the oceans. We have a a pathway that is terrestrial in that it ends up in the aqueous streams, the wastewater streams, or runoffs from particularly urban areas. And this is anything to do with the domestic wastewaters that are generated. We've heard also, or you're probably familiar with, that there have been quite a few reports on if you wash a fleece jacket, you will end up with lots of fiber microplastic particles in the wastewater. But on the mostly on the urban areas, but roads also, there's a lot of wear and tear that because of the surfaces are impregnable, they are washed off and end up in surface water, which eventually come into the ocean. The other pathways are essentially wind from the terrestrial environment. A lot of dust is created. We are quite familiar with that here in Trondheim in terms of air quality. And a lot of those particles then, mostly from traffic, but also from other sources, can be blown blown out and into the ocean. And then there is this source, of course, in the activities that are carried out at sea. And as we know, the fishing industry is using a lot of plastics. A lot of that we often see on beaches after a storm. But it's also been mapped, and we have that as one of our programs at the Marine Institute of the Marine Research Institute that maps the actual garbage that we find during the Mariano program lying on top of the ocean floor. And a lot of that is nets, ropes, all kinds of different plastics. The global releases of plastics into the oceans is illustrated on this slide here. And we see a total of plastic waste that is then released from the continents, as illustrated here with these different diagrams, into the oceans. And then the little column on the right is the component of microplastics. What is interesting, of course, to see that the total amount of plastics is relatively low in North America and Europe compared to the microplastics, whereas the total amount of plastics is much larger on the other continents. The numbers that are used today are roughly 10 million tons per year of input of total plastics into the marine environment. That's a lot, 10 million tons. And about 1.5 million tons of microplastics per year. So what are the sources of these microplastics into the oceans? There are illustrated here on this particular diagram, but what is interesting is to see that about 2/3 of that input is ascribed to synthetic fibers from textiles and also from the wear and tear of tires and of road surfaces. If we consider that the total estimated input of microplastics into the oceans is about 1.5 million tons, that means that this 2/3 represent about 1 million tons. I know there's a bit of a discussion going on in terms of do we really have so many particles, microplastic particles from tires, because that is still not confirmed. But we certainly do have also a large component of city dust that comes in. And what is most noticeable, of course, is that many of these are primary products. So a little bit about the microplastic properties in seawater. That's primarily the density. And here I've just summarized it in terms of density and the type of plastic, thermoplastics, relative to the range of seawater density. And as you can see, there's not a very big difference in terms of the density, except for maybe polyester, PET. But we certainly see that polystyrene is one of those products that we often find on beaches. It's also the one that is easily blown from the terrestrial environment into the aqueous environment. Yeah, on the right, I've given some typical uses of these different types of plastics that you probably recognize then. But many of the, for instance, polypropylene, the rope materials, are quite light and they float. So floating plastic debris we find in the middle of the oceans. They accumulate and get entangled, or they get washed up on the beaches. Amy already showed that as well. So there were groups that were trying to establish, with so much of this plastic floating, and in here is a lot of microplastic as well, because the exposure to the sunlight causes these plastic to degrade. And where do we have ocean currents that maybe accumulate these floating debris, floating garbage? So there was a study done where they looked at the ocean currents, the gyres, and then found that there's certain areas in all the oceans where these floating garbage accumulations would be highest. And then the interesting thing was that there was a study where in circumnavigation, they took samples of ocean water, tried to establish the correlation between the modeled accumulation zones and the actual observed amounts of plastic in samples that were collected. So here you can see that there is indeed a good correlation between where they were modeling that there could be large accumulations of floating debris in terms of the oceanographic conditions, the currents and the densities, and the actual observations from samples that were collected. This is called the Malaspina circumnavigation. I will come back to that in the later slide. What is then observed is that there are some huge floating garbage patches in the oceans. And in fact, they are quite thick, and they are just below the surface because the density is such that, in relation to the seawater density and temperature effect, they could be quite thick and they float around. And the waves and currents contribute to these patches stay together. The microplastic abundance in the oceans, if you look at these samples that were collected then, at the size distribution of plastic particles in these samples, we can see this distribution here, and it was noticed that there is quite a low occurrence of plastic particles with a size less than 1 millimeter. So that is being looked at as well, as maybe we should look at microplastics in this case as being particles less than 1 millimeter instead of less than 5 millimeter. So the question is then, are the oceans a sink for plastic waste? The estimated total annual input is, as I mentioned before, 10 million and about 1.5 million tons of microplastics. But the actual estimated amount of floating debris that has been mapped is much lower. And then the question is, where is all the plastic then? All the plastic that we know will enter into the oceans, and we don't find that if we do the budget modeling of the actual sample data that we have. So it's probably lost at sea. Why would plastic be lost at sea? This diagram illustrates also how, in terms of the properties and the processes that occur, we see, for instance, that some shore deposition occurs, Like here is the example photographed in Taiwan of polystyrene floating up on the beaches. Where we also have the fragmentation that occurs of plastic particles, so you can get a very turbulent water that, if it comes in contact with the current, of course, gets swept away into different areas. And we can see that it's being consumed, ingested by fish or by plankton, and that's quite abundant. That's quite a high percentage. And then, of course, by increasing the density of the particles, you can get sedimentation. They sink through the water column and they end up in the seabed. And this is, among other things, by absorption or attachment. This is illustrated here with a little bit bigger particle. But we know, for instance, here is a picture of a microplastic particle with bacteria that have attached themselves and embedded themselves into the plastic. And then, of course, they increase their density and they sink. So sedimentation of plastic in the oceans is plastic debris, macroplastic, is laid down on the sea bottom, but microplastics can easily be deposited in marine sediments, in this case illustrated by a beach sand deposit. And you can see that it's actually inside the layers of sand-rich sediments. So sedimentation of marine particles in the oceans, we have different types of environments. We have high current, high energy environments, but we also have much lower environments, such as the deep sea or semi-enclosed seas. We have the Baltic Sea and the Mediterranean. We have the continental shelves and the deep oceans, where we all find microplastics in the marine sediments. And this is by now an increasing amount of data from studies carried out all over the world. And they've confirmed that almost every sample of marine sediment that's taken of the top layer, they find marine plastics, microplastics. So an interesting modeling exercise is that if, let's say, sediments were only found on half of the ocean floor, you already would have a significant sequestration of microplastics from the oceans. In other words, they are extracted from the sea. This is just results of the study we've done in Mariano. We found in different settings here, both in fjords along the continental shelf in the deep sea, we find microplastics in the marine sediments everywhere. And the same in this study that was just published in December by Amy from NIVA for the Miljödirektoratet, and it also includes, marine sediments, and microplastics were found there as well. So do we see an increased input of microplastics into the oceans? Well, the result that we see today is from about 70 years of plastic production. And here you can see a prediction of this earlier prediction of the amount of plastic that will be produced. The data I found was that for 2015, it fits that trend. But what is disconcerting is also that the American Chemistry Council says that so much money is being invested, and we know that, in new plastic plants, which certainly means that they're going to produce more and more plastic. So it's been described as the ocean Armageddon for the future. In fact, and this is my last slide, one researcher said that by 2050 there'll be more waste plastic in the sea than fish. So with this, I'd like to thank you.